how does our brain hallucinate our conscious experience?
That's a good question to start with. The reason I use the term hallucinate, I actually use the term controlled hallucination. I think the control is just as important as the hallucination. Otherwise, you get into all kinds of tangles and end up saying things like the world doesn't exist or that everything we experience is made up. And it's a metaphor, and like all kind of linguistic metaphors, it's useful but also potentially misleading. What it points to is this claim about how conscious perception works. And this claim has a very long history, and it goes back to Plato, goes back to Immanuel Kant in philosophy, goes back to Helmholtz in psychology and physiology. And the basic idea is very simple. The basic idea is that the brain has no direct access to the world or the body. It's locked away inside this bony skull. And so it has to make an inference about what's out there on the basis of the sensory signals that it gets, the sensory signals that come in through the eyes and the ears. You know, they're only indirectly related to what's out there in the world. They're noisy, they're ambiguous, they're uncertain, they're unlabeled. So the idea is the brain is doing something like Bayesian inference. It's saying, okay, here's what I believe now about the state of the world and the body, and here's some new data. So how should I update what I believe now on the basis of this new data? And there are two claims here. The first claim is that the brain does this by continually generating predictions about the sensory data that it's expecting to get in levels across this hierarchies in the brain. And sensory input in this view isn't something that's read out by the brain. It's rather prediction error. It's the difference between what the brain expects and what it gets. And so the brain uses sensory data to keep its predictions tied to the world. And in doing this, it can sort of solve this problem, at least approximately, of Bayesian inference, of inferring in a best guess the most likely causes of sensory signals. So that's kind of a claim about the mechanism in the brain. And the second claim, at least for me, is that what we consciously experience is not a readout of the sensory signals. It is rather the content of the brain's predictions. So it's sort of coming from the inside out, calibrated by the outside in sensory signals. And that's why I use the term controlled hallucination, because it connotes something like experience being internally generated, but controlled by sensory signals from the world and the body.
It's such a cool idea. I think it's one of the most profound ideas I've ever read about or come across in neuroscience, is this idea of perception. Do you think, can we know if there are any senses or aspects of our conscious experience that are more hallucinated than others? Like, is our vision more hallucinated than our auditory perception or our interoception or all of the other senses that we'll get into?
That's a good question. I don't know if it's easy to characterize things that way. There's a constantly shifting balance even within a given perceptual modality. So when you pay attention to something in vision, for instance, really, really like focus on it, even if you're not looking straight at it, you might focus on something in your mind. What's happening there, or at least what people think is happening there, is that your brain is rather placing extra weight on the sensory signals rather than on the predictions. So in that sense, you might say your perceptual best guess becomes a little more tightly controlled by the world and a little less hallucinatory.
Right.
But in another sense, all of your experience is always all hallucinatory, because that's kind of the core claim, that what your experience is the top-down prediction. It's not the bottom-up sensory signal, but the degree to which the bottom-up sensory signals affect the top-down predictions, that can change. Whether there's like systematic differences across different perceptual modalities, I don't know. There certainly could be between people. So when people actually have the kind of hallucinations that we commonly use the word for, maybe they have schizophrenia, maybe they have other conditions that lead them to have experiences which kind of lose their grip on the world and the body in some significant way, well, then it's reasonable to say that they are hallucinating more than other people because their perceptual inferences become less controlled by the world and the body.
Right. What is it about our peripheral vision that seems to make bad predictions more often? So one example of this that I always have is that I'm walking down a busy street and I will glance and I will so frequently think that I see famous athletes on the street. You know, like the amount of time when I moved to Barcelona, I was like, that's definitely Messi. That's definitely, and it will always be at a glance. And then I'll look back at them and I'll just realize that there was, you know, a Messi shaped person, or like
what's a Messi shaped person? Like somebody
generic brown hair, white, small, 5'8", wearing an Argentina jersey, maybe. You know, exactly. I was going to ask that. I'm kind of curious, like, what are the features in the brain as well that it's really integrating to make this prediction? Like, is there hundreds? Is, you know,
Well, were you ever right? Was it ever Messi or was it never Messi?
Not yet. But I'm
Okay.
still combing the streets of Barcelona to find him someday.
How about he's in isn't he in Miami now? Anyway,
He's in
you'd be
Miami at the
lucky.
moment. Unfortunately, he left a few months after I arrived. But for some reason, interestingly enough, my predictive model hasn't updated that information.
Right.
Maybe or maybe it has. I can't tell.
No, but that there is an interesting point, right? Because you so strongly associate Messi with Barcelona
Yes.
that even though you know on some level that he's not there, your brain is still expecting it to be the case at some level, right? And this is interesting because there are some visual phenomena that, however much you know about them, you still can't help seeing them in a particular way, and we call these visual illusions cognitively impenetrable. So a classic example is something like the Muller-Lyer illusion. These two lines which are the same length, you can measure them, you can know that they're the same length, but they will always look different. So you seem to have a kind of cognitively impenetrable Messi illusion, which is, I haven't heard of that before. But I think, we're drifting off the question that you asked, which I've already forgotten what it was.
Was it related to? I can't remember either. I thought it was an interesting tangent anyway, worth going down. But you brought up optical illusions.
Oh, peripheral vision. You asked me about peripheral vision.
That's it.
And so, in some sense, peripheral vision is not as good as central vision. I mean, it's if you just look at the basic neurophysiology or physiology of the eye and the retina, it's very clear that there's a massive density of light-sensitive cells in the part of the eye that is at the center of the visual field, or that rather represents the center of the visual field. And things drop off quite quickly as you get further away. On the other hand, our peripheral vision is much better at detecting things in low light and things that move. Now, you can imagine all kinds of evolutionary stories about why this is useful. When it's dark, it's really good just to be able to detect approaching threats, and it doesn't quite matter so much what they are. But during the daytime, you really want to be able to see what you're looking at, see if it's food or what kind of food or something like that. But certainly it's the case. And one interesting thing that's always struck me about peripheral vision is that there are very few cells out there that are sensitive to the different wavelengths of light that we commonly call red, green, and blue. And yet it seems to us most of the time that we see color pretty uniformly throughout the visual field.
Right.
And so there's something, there's a colleague of mine, well, I mean, I'm published with him, but somebody else I know in the field, Michael Cohen, who's done these pretty cool studies using virtual reality where he can drain the peripheral vision of color. You can wear a headset and you can look around and basically the periphery starts to become black and white. Now, you don't notice this. This is the crazy thing. If you've got the headset on and it's tracking where your eyes are, so it's moving where, what's colored and what's black and white depends on where you're looking. And if you're the participant in this, you don't notice that suddenly a lot of the actual sensory inputs just drained of color. You still just sort of see it in color. If you're looking at what the other person is seeing, it's very obvious because, it's not tracking your gaze now. So you can suddenly see that, wow, it's basically gone black and white. They don't notice. And there's another illusion, something we're studying in my group actually, called the uniformity illusion. And in this case, if you look at like the center of a particular kind of image. Let's say the center has a bunch of lines all oriented in one direction, 45 degrees mainly. And then in the periphery, there are lines that are oriented in all kinds of random angles. Now, if you look at it for a few seconds, what tends to happen is that the periphery of your vision becomes, the appearance of it takes on the appearance of the center. So it suddenly looks like all the lines are oriented the same way. So you have this kind of illusion of uniformity. And this is really, really striking to me. And it sort of suggests that what's going on, at least in this case, is that the brain is kind of relying on the idea that central vision is more trustworthy, there's more detail. So, and it has this higher order belief maybe that everything else being equal, things across the visual field should be the same. And you put these together, and that's why then after a while you sort of see the visual field as uniform. Now, I mention this just because it's a really good experimental way into understanding some of these questions that you're asking. I mean, this is precisely the name of the game. We want to, unpack exactly how the brain balances these top-down predictions and bottom-up sensory information to form not just our perceptual decision about what's there, but actually our perceptual experience. That's what I'm interested in as someone interested in consciousness. Why does it seem that the whole visual field is uniform or full of color when it isn't?
Right.
And so we can do these things to get at these questions. There is no single answer yet.
If you enjoyed that clip with the legend Anil Seth, then you really have to go watch our full-length conversation. It was the best episode I've ever put out. I'm really happy with it. Go watch it now.